The question we are solving now belongs to test series 5. It is of signals and systems subject. In specific, it belongs to Laplace transforms. As per the question, the input-output relation of a LTI system is given by the relation or is given by the differential equation d square y by dt square plus y is equal to x. It is given that this LTI system is fed with an input of x of t is equal to k multiplied by e power minus 3t u of t. We need to find the response y of t for t greater than or equal to 0. For finding the response y of t, first let us take the Laplace transform of this given differential equation on both sides. Upon doing that, we get that Laplace transform of d square y by dt square plus Laplace transform of y is equal to the Laplace transform of x. Please note that here it is given that the circuit is initially relaxed, or rather say the system is initially relaxed. We know that Laplace transform of d square y by dt square can be written as s square into y of s minus s into y of 0 minus y dash 0 plus y of s, which is the Laplace transform of y of t, is equal to the x of s, which is the Laplace transform of x of t. As the circuit is initially relaxed, y dash is equal to 0 and y of 0 is equal to 0. So this can be further simplified as y of s is equal to x of s divided by s square plus 1. It is given that x of t is equal to k into e power minus 3t u of t. The Laplace transform of the same, that is x of s, can be written as k divided by s plus 3. So upon substituting, we get that y of s is equal to k by s plus 3 multiplied by s square plus 1. Now for finding y of t from y of s, we need to find the inverse Laplace transform of the quantity marked. For doing the same, let us split the marked quantity into partial fractions as a by s plus 3 plus bs plus c divided by s square plus 1. So this can be further simplified as a multiplied by s square plus 1 plus bs plus c multiplied by s plus 3 divided by s plus 3 multiplied by s square plus 1. This is upon summing up these two quantities. Now let us equate the numerators. Upon equating the numerators, the coefficient of s square is equal to 0. So therefore a plus b should be equal to 0. This is because the coefficient of s square on the right hand side comes to be from r and b. Similarly, upon equating the coefficient of s, we see that this also should be equal to 0. So c plus 3b should be equal to 0. And the constant term should be equal to 1. From this we can say that 3c plus a should be equal to k. So based on this data, we see that a is equal to minus b, and we also see that c is equal to minus 3b. So upon substituting these two in 3c plus a is equal to k, we see that the equation can further be simplified as minus 10b is equal to k. So that implies b is equal to minus k divided by 10. From this we see that a is equal to k divided by 10 and c is equal to 3k divided by 10. From this we see that y of s is equal to k divided by 10 multiplied by s plus 3 minus ks divided by 10 multiplied by s square plus 1 plus 3k by 10 divided by s square plus 1. Now let us take the inverse Laplace transform on both sides for above. Therefore y of t is equal to L inverse of y by s is equal to k by 10 multiplied by L inverse of 1 by s plus 3, which can be written as e power minus 3t u of t minus k by 10 multiplied by L inverse of s by s square plus 1, which can be written as cos t u of t plus 3k by 10 multiplied by L inverse of 1 by s square plus 1, which can be written as sin t u of t. From this we see that the response of the system can be obtained as k by 10 e power minus 3t u of t minus k by 10 cos t u of t plus 3k by 10 sin t u of t. So this is the response of the given system for an input of x of t is equal to k into e power minus 3t u of t. Hence we see that the correct option representing the response of the system for the given input is D, which corresponds to none of these.